Hello everyone, welcome back to my channel. I am Vishit Ramesh and today in this video, I am going to be talking about the geometric transformations on various objects. So let's get started. So first, the basics of geometric transformation. So geometric transformations are a fundamental concept in computer graphics and image processing, enabling the manipulation of objects and shapes in a digital environment. These transformations allow for the precise positioning, rotation, and scaling of visual elements, empowering designers, artists, and engineers to bring their ideas to life in innovative ways. So let's look at the basic geometric transformations available in real life. So the first is translation. It consists of positioning, relative coordinates, and versatility. So what is positioning? Translation is the process of moving an object from one location to another within a coordinate system. This transformation allows for a precise placement of objects, enabling designers to arrange elements on a canvas or layout in a way that enhances the overall composition and balance of a design. Relative coordinates. In computer graphics, translation is often achieved by manipulating the object's coordinates relative to a reference point or origin. By changing the x, y, and z values, the object can be moved to any desired position, allowing for infinite possibilities in scene composition. Versatility. Translation is a versatile transformation that can be applied to a wide range of visual elements from simple shapes and text to complex 3D models. This flexibility makes it an essential tool for designers, architects, and animators, enabling them to create dynamic and visually engaging content. The next is rotation. It consists of rotation, angle and pivot, visual impact. Orientation. Rotation is a process of turning an object around a specific axis, allowing for the adjustment of its orientation within a scene. This transformation is particularly useful in 3D modeling and animation, where characters and objects need to face different directions or assume specific poses. Angle and pivot. Rotation is defined by an angle of rotation and a pivot point around which the object will turn. By manipulating these parameters, designers can achieve a wide range of rotational effects from subtle tilts to our full 360-degree spins. Visual impact. Rotation can have a significant impact on the visual perception of an object, altering its shape, perspective, and overall aesthetic. Skillful use of rotation can create dynamic, eye-catching compositions and enable the exploration of different viewpoints and compositions. So scaling. It consists of side adjustments, proportional scaling, emphasizing details and responsive design. Size adjustments. Scaling is a process of resizing an object, allowing for the adjustment of its dimensions and overall size. This transformation is crucial for ensuring that visual elements are proportionate and fit within a specific layout or design. Proportional scaling. Scaling can be applied uniformly across all dimensions, preserving the object's original proposition, or it can be applied selectively to individual axes, enabling the creation of distorted or exaggerated shapes. Emphasizing details. Scaling can also be used to highlight specific details within an object, drawing the viewer's attention to particular elements or features. This can be especially effective in technical illustrations, product renderings, and data visualizations. Responsive design. In the context of web design and user interface development, scaling is a crucial technique for creating responsive and adaptable interfaces that can adjust to different screen sizes and devices. So, the applications of geometric transformation, engineering and manufacturing. Geometric transformation are essential in engineering and manufacturing, where they are used to design, optimize, and simulate complex 3D models and prototypes. Graphic design and animation. In the realm of graphic design and animation, geometric transformations are fundamental tools for creating dynamic and visually engaging content. Education and visualization. Geometric transformations play a crucial role in educational and visualization applications, where they are used to create interactive simulations, infographics, and 3D models. Medical imaging and diagnostics. In the field of medical imaging and diagnostics, geometric transformations are employed to analyze and manipulate medical scans such as X-rays, CT scans, and MRI images. So now let's look at the live example of the geometric transformations on two objects, that is a triangle and a rectangle. So let's get started. So now we're going to be looking at a live demonstration of applying geometric transformations on two objects simultaneously. Let's get started. So first we're going to be importing the libraries. So we're going to be importing Pygame, importing Pygame locals, OpenGL, and GULAT and GLU. These are used for importing the OpenGL modules, GLUT or module which is for providing utility function, and then GLU module which provides higher utility function. And then we're going to be initializing Pygame and set up an OpenGL display. So pygame.init is basically initializing all the Pygame modules, and then we're going to be setting the output display size to be 800 into 600. So then we're going to be setting up the output display with double buffering and with OpenGL support. And then we're going to be setting the background color to white. So next is setting up the view. The GL matrix for the GL projection used for the current matrix mode projection defines how objects are projected onto the screen. And then we're going to be resetting the current matrix to the identity matrix. And then we're going to be setting up a 2D orthogonal identity by dimension. And then we're going to be set the current matrix mode to model view, defines how objects are transformed in 3D space. And then we're going to be defining about the triangle properties. So first we're going to be displaying the initial position of the triangle, and then we're going to be setting the initial rotation angle of the triangle to 0, and then the initial scale of the triangle to 1, and then the rectangle properties that display is the initial position, the angle, and the scale. So this is about the drawing of the shapes, the draw triangle and the draw rectangle. So these are basically the properties of the shapes. So first it's going to be defining about how to draw a triangle to specify position, angle, and scale. Push matrix is nothing but says the current matrix. GL translate function translate the triangle to a specified position. GL rotates the triangle by a specified angle around the x-axis, around the z-axis. And then GL scale 1 scales the triangle by a specified factor. And then we're going to be drawing the triangles. This is for setting the blue color. This is the position of the top vertex. This is the bottom left vertex, and this is the bottom right vertex. And then we're going to be ending the drawing. And then this restores the previous matrix. And now we're going to be drawing about the rectangle. Again, the same properties. We're going to be defining the rotate, translate, scale, and then the color of the shape, which is the red color. This is the other 4 vertices: left, top right, bottom right, bottom. Then we're going to be ending, and then we're going to be resetting. So now we come on to the main loop. Running is equal to true, which is we are going to be setting the flag to be true to the starting of the loop while running. So basically, what happens is here starts the main loop. For event in Pygames, it processes the Pygame events, which is basically the different keys when we are pressed. Then if event is equal to pygame.quit if the event has been triggered, and then running is equal to false, the running packs to exit the loop. So keys is equal to pygame.key.get pressed, which is the keys we're going to be pressing on keyboard. So controls for the triangle. These are basically the various keys which are going to be used for translating for geometric transformations on these two objects. So key.left is for translating left, right is for translate right, translate up for up, translate down for down, rotate counterclockwise, rotate clockwise, scale up and scale down. So these values are basically by how much should the shape be moving in its respective key when the respective key is pressed. Same is for rectangle, which is the same keys has been given for the same as for triangle. And then we come to the GL color buffer bits. So like what it basically does is clear the screens by filling it with the background color specified earlier, which was white initially. And then we have the draw triangle shapes, the current position and the current rotation angle and the current. And then we have the draw rectangle, current position, current angle, and the scale. The pygame.display.flip is used for full display surface to the screen. This has a double buffer, effectively rendering the new frame to the screen. Pygame.tighten wait is for waiting for 30 milliseconds, which helps control the frame rate of the application. Pygame.quit. This is used to shut down all the Pygame modules. This should be called when the program is done running to clean up the resources properly. So now let's run this program. So this is the output we're going to be displaying. So first we're going to be moving up the shapes, coming down, moving right, left, increasing the size, scaling, and lessening the size. And this is counterclockwise rotation. And this is clockwise. As you can see, both the objects are being moved simultaneously. They are touched. Thank you everyone for watching this. I hope you now have a better clarity on the basics of geometric transformation and also saw a live demonstration on two objects. Please like, share, and subscribe to my channel. Thank you.